All right. So we had a little hiatus that's called a break because yesterday majority, if not all, of this class had to take the PSAT. Yeah, I am recording. I mean, we're live and stuff. Don't forget, hit like, hit subscribe, hit the bell. Today we are doing something I think most of y'all can do. Today we are multiplying and adding. And if you have issues with either of those, please get a calculator. Okay, so the product of powers property. Basically, look, they have these fancy words. Basically, it's this: two powers, same base, add the exponents. For example, we have 7 to the third times 7 to the sixth. Well, what's 3 plus 6? 9. Okay. All right. Let's zoom in a little bit more. All right. So this is hard right here. So let's see. See, this is 2 to the 4 plus 6 plus 2. All right. 4 plus 6 is 10. And then 2 more is 12. So this becomes 2 to the 12th. That's it. All right. Number 2, we have -5 to the -2 and -5 to the 7. Well, -2 plus 7. All right. So -2 plus 7 is the same thing as 7 minus 2, which is 5. Yeah. Whoops. I just boxed over. Okay. So, yeah, I'm not a big fan of the time multiplication test. It's, yeah. Oh, okay. Yeah. All right. Getting off track. Okay. So, in other problems, we're going to multiply the number and add the exponents of the same base. For instance, we have 2x squared and 4x to the fifth. Well, 2 times 4 is 8, and then 2 plus 5 is 7. So let's do this. Let's pull out the numbers first. All right. So 2 times 9 times 3. Uh, yeah, is 54. All right. So, all right. It looks like we have a to the first and a to the second. So what's 1 plus 2? 3. Awesome. And there's no other b's, so we're just going to put it all together now. Okay. Now, I kind of break mine down. Break it on down. This way, like I pull the numbers and I do them in a line. I pull the bases, I do them in a line together, and then I just kind of smush it all together at the end. Okay. It's kind of like, so Tuesday I was eating some gummies during refuel, and people watched me because I put them in color order and then eat them. I do. Yeah. Yeah. I did tell a student that no, I did because I did tell a student that eating hot pizza was weird because they specifically said that cold pizza is gross. So, So number 4. All right. So 13 times 3, that is 39. Why did I write 6? I Yeah. You want me to double check? I mean, I will. There we go. All right. Now, with our x's, we have -8 plus 10. -8 plus 10, same thing as 10 minus 8. And then we just put it all together. Hmm. Okay. Now, for those still actually paying attention to math, power to a power property, you multiply. Okay. So this one right here, this is x to the third, all raised to the 5th power. So what's 3 times 5? 15. Listen, I took my special vitamins this morning and I can't hardly pay attention to what I'm doing. There's like 16,000 other things going on and it's tough. Okay. So this, number 5, this is n to the 4 times 7, which is n to the 28th. Okay. This is p to the 5 times 4, which is p to the 20th. Ooh. Number 7. Number 7 looks a little bit more difficult. That is a really good thought. But you are actually the only person that tried, so I very much appreciate it. So let's think about it. Order of operations. Yeah, she just literally just said that. This is the only thing that's raised to the exponent. The x to the 6th. Let's get a closer look. Yeah, because this is a parentheses exponents. Yeah, PEMDAS. Oh my gosh. Yeah, so we have to do this first. All right, 6 times 4, 24. And then 24 times 2 is 48. So lots of fun. This is odd. We actually have less people in the class, but there's more noise. Okay. I mean, I like it. All right. So now you could probably tell if you're reading the notes or somehow paying attention that I stuck with the very basic, this is what you would see in the math book uh, definitions for this stuff. And then I got tired and bored with that. And then I said that this one is like distributed property on steroids. Okay. So let's step through this. Watch where you're putting your feet. All right. So so this part right here is all of that is what is being raised to the second power. Okay. Now, some people will have to do it like this. Some people will have to say this is 5y to the third times 5y to the third. 5 times 5, 3 plus 3. You're going to get the same answer. Okay. But if you think about it like this, we're actually going to use the distributive property with the exponents this time. You could do either or. Now, some of y'all are like, that doesn't make a whole lot of sense. Well, I've done one. Okay. So let's do some more. There we go. All right. So all of this is being raised to the third. Now, look, it's holding it in parentheses. I really doubt it. I'll probably be saying it later this semester because this is actually read in the math nerd world as 7m to the ninth quantity cubed. That means all of it. That's actually how you would say verbally that they're in parentheses. I know, it's weird. So let's do this. We'll have to say 7 to the third. And then we say 9 times 3. All right, 7 to the third power is a bunch, I bet. 343. And then 9 times 3 is 27. Okay. 27. So this whole answer okay. Now, if you are one of these people that the distributed property on steroids doesn't click with, there is nothing that says that you cannot do this. They're like, well, that's too much work. You got to pick your poison. Okay. It's the lesser of two evils. Huh? Hmm. All right. So, speaking of evils, hey, Snacks, what is Chucky's favorite game? Hide the soul. Very good. All right. So, Chucky from the Child's Play, a serial killer hides his soul in the doll and he keeps transporting his soul. Okay. Okay. Awesome. Oh. All right. So 2 to the fourth power is 16. So all this now becomes 16w to the fourth. Now, this was understood to be w to the first. Okay. That was understood to be w to the first. Yes. Yeah, there's not an exponent in this problem. Yeah. Yeah. See, the inside number on number 8, yeah, is only to m, and it's 9. Mm-hmm. All right. So this is 3 squared, then x to the 4 times 2. So this is 9, x to the 8th. Now, this sounds weird. I've actually been doing this process with these type of problems since I took Algebra 1 way back in like 1993, 94. Okay. Yeah. A long time ago. Before the internet. All right. So that's 8, 9, and 10. All right. Last thing, and this is my favorite. Also, I don't know why there's a rogue 1 sitting out here. Just, well, it's like I was going to have a 13, and then I didn't do anything with it. So we'll just mark that out. That's just a happy little accident. All right. Anything to the 0 power is 1. I know that doesn't make sense, but what was commonly used like Tylenol back in these times when they were making this stuff up? Opioids, opium. And opium is how you get, you know, morphine, heroin, that kind of stuff. So basically, they were on drugs. Okay? All right. So I gave an example. Here's 5,723 to the 0 power. That becomes 1. All right. 9 to the 0 power is 1. Negative 3.6 to the 0 power is 1. Okay, we could have 50 bajillion to the 0 power, and it's still going to be 1. Okay. All right. That's where we're stopping our lesson. Our in-class audience actually has some work to do on the back page of their handout that we're going to go over. Don't forget, hit like, hit subscribe, hit the bell, leave a nice note. I would like that. You know, a lot of people, they don't like math teachers. Okay. Good stuff. Good things. Stay sparse. What? Roll Tide. Go off, go off, go off.